Alright, this continues our classwork night 12. We are going to be working on problems 7 and 8 in this video. So in problem number 7, the first thing we need to do is we need to put the problem into slope-intercept form. So we start with 4x minus 5y and put it in slope-intercept form. Of course, we need to put the x on the other side, need to get it away from the y. So we're going to add its opposite to both sides. So we'll have a negative 4x added to both sides. And that's going to give us a negative 4x plus 20 equals a negative 5y. So negative 5y, negative 4x, and then plus 20. And finally, we need to get rid of that numeric coefficient, so we'll multiply by the reciprocal of that in all three terms. And remember, that looks like division because it is. Now we have positive y is equal to a negative divided by a negative, which is a positive, 4, and that would be fifths x, and then minus 20 divided by 5, which is 4. Now we have it in slope-intercept form. So that was part A. Now part B is to put this, give the slope. So the slope, remember, is the numeric coefficient of the x term. So the slope of this, this is 4/5, so we'll put 4/5 right here. And then the next thing that we want to do is we want to give the y-intercept as an ordered pair. The y-intercept, remember, is the coordinate of the, or the constant of the expression. So we have a negative 4 here, and the ordered pair always looks like x equals 0 and y equals that value. And then for part D, it says to give the x-intercept, and we want to show our work. The x-intercept is when we let y equal 0. And so y equals 0, we're going to do that in the original equation. So we have 4x minus 5 times 0 is equal to 20. And then we'll have 4x is equal to 20. So we'll multiply each side by the reciprocal here and here. And therefore x is equal to 5. And finally, we'll go ahead and write that as an ordered pair, and that will be our answer to D. So x is equal to positive 5, and y is equal to 0. And so now what we have is the y-intercept and the x-intercept. And we know when we're looking at a y-intercept, remember, because x equals 0, and we know we're looking at an x-intercept when the y is equal to 0. Now in our next problem, what we have, or part of the problem, it says that we need to find the slope of the line that's perpendicular to our line at hand. So remember, being perpendicular means that we have a slope that is negative reciprocals. So our slope is 4/5. And so if we're going to be looking for a slope that is a negative or a perpendicular slope, that first of all means that ours is positive, so we're going to have a negative, and then we have the reciprocal, which would be 5/4. Now, once we have that, the next thing says give the equation of a line that's perpendicular. So if we're looking for a line that's perpendicular to this, we know that we have y equals, and then we'll use the slope, negative 5/4 x, and they've very generously provided us with the y-intercept of the line. I know that it's the y-intercept of the line because, of course, the equation, or the ordered pair, has x as a 0, so I know that's my y-intercept. So I've just plugged this into the slope-intercept form, and therefore I have the equation of my line that is perpendicular and going through the point 0, 4. Now in my next part, I have give the equation of the line that's parallel. So again, my line slope is 4/5. So if I want a line parallel to my line, parallel slope would be the same exact slope. So line parallel would also have a slope of 4/5. Now this time around, we haven't been so generous. We don't have the y-intercept. So this time we're going to have to use the point slope form. So we have y minus the y-coordinate is equal to the slope times x minus the x-coordinate. And so we have minus, and that's a -2. And then we're going to simplify. So first off, we're going to distribute, and that it's 4/5 times x, so 4/5 x is how we write that, and then 4/5 times a positive 2, because the opposite of a negative 2 is a positive 2, so that gives us plus, and that's 8/5. And then I'm going to go ahead and I'm going to add positive 5 to both sides, but I'm going to get prepared because I know I need fifths, and so remember that this is over 1, so times 5 here, so times 5 up here as well, and that's going to give me 25/25. So over here I'm going to be adding and then 25/25. And so, oops, 25/5. And so now I see that I get to add both of those, and my answer, y, is equal to 25 plus 8, which is 31/5. So we have 4/5 x, and then plus 33/5. So 33/5. And that's perfectly acceptable to leave as the answer there. So now that I have my final answer, then I'm able to go ahead and move on to the next question. Okay, so my problem number 8, what I have on my problem number 8 is that I have to find if these things are functions. Now remember, there are many ways to tell if something's a function. One of the things that we're looking for is that every x only has one y. If we're looking at a set of ordered pairs, that means it's quite easy to find these to be functions or not, because we have only to look at the x values. So here I see that I have 2 of the same x's, and a quick check of the y's I see that they're different, so this is not a function. And the reason that it's not a function is, again, because there are repeated x's. So not a function because repeated x's, with different y's, to be totally specific about that. So let me finish writing this, and then we'll move on to the next part. Okay, now the next part of this, the second part of the question says give the domain and the range. So domain, we like to abbreviate that with a D, so I'll put a D with a colon, and then I can list these out. So I'm going to use a roster form. 3 and 4 and 5 and 6, those are my x values. X, the outputs, the independents, those are all the same names, or different names for the domain. Now the range, those are our dependents, our y's, our outputs, and I'll list those in order from largest to smallest: 15, 18, 21, 24, and then 27. So those are the range values. And then the next question that it asks us is, it asks us to determine whether this function is a linear function, and if it is indeed a function. So this one is not even applicable to us, so we'll put just not applicable. And then we're on to our next problem. So again, we have a set of ordered pairs, and so as I look at this set of ordered pairs, what I'm looking at is having whether I have any repeated x's. So I look down, 0, 1, 2, 3, 4, no repeated x's. So this one is a function, and it is a function because there's no repeated x's. And therefore I am guaranteed that it is absolutely a function. Now the next thing I want to find out are what the domain and range are. So when I look at the domain, I see that I have a set of values here: 0, 1, 2, 3, and 4. And so that's my domain listed in roster form. Next, my range, my output, my dependent values, my y's. There's only one, 7, and I don't have to repeat it just because it's repeated here. Now my next question is the relation if the relation's a function, indicate if it's linear. Well, linear means I have constant slope. So yes, this is a constant, or it is linear. because it has constant slope, and that is the long and short of it. And the way I find if something has constant slope, remember, is that I look at the change in the y's and then the change in the x's and compare change in y's to change in x's, and each and every time it's the same. So the change in y's, remember our way of looking at that is delta y, to the change in the x's, that is equal to 0, and it's constant. So that is what we're looking at, that we have constant slope. All right, now our last one, what we have to be able to do in order to tell this one is a function quite easily is to be able to recognize this as a cubic function. And cubic functions have a very specific looking graph. Remember, we learned about these earlier, and we learned that these type have a graph that looks something like this. And if it looks like that, then it passes a vertical line test. And because it passes a vertical line test, then we know it's a function. So those are the methodologies of getting through this one. And that's one of the nice things about knowing different types of functions and what their graphs look like, because we can tell if they are functions or are not a function. And so now I can say, therefore, it's a function. And this one, the domain and the range, finding those, well, the domain, any value of x can be put in there. So we're going to say that that's all real numbers. And the range of this, well, eventually all values of the numbers will come out. So again, all real numbers for those. And remember that either the all real numbers symbol, or we could use interval notation, saying from negative infinity to positive infinity, just like that. And then finally, is it a linear function? Well, no, it's not a linear function. It's not a linear function because we can see that it's not a line. So not a linear function because it's not a line. And basically, the reason that we know that it's not going to have constant slope is because you could see the slope along here has one slope, and then as it goes here, it has another slope, and a different slope here, and a different slope here, and a different slope here. So that is not a linear function. So it's not a linear function because it's not a line. And that is number 8. So let's move on up to number 9. Number 9, we're looking at